Hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. I would like to thank Almighty my God for my good health and broad mind, and I would like to thank my friends, followers, my dear students and subscribers for their continuous support and encouragement. Today's topic of interest is unconventional machining process. So, before seeing unconventional machining process, we would like to share what is meant by a conventional machining process. In conventional machining process, the work and tool is directly get interacted, and by means of a shear force the metal unwanted material is removed from the workpiece. So here the direct contact of tool and workpiece is come together, and the force and stresses between the tool and workpieces happens, and then only the unwanted materials can be removed from the work material. So that is called conventional machining processes. Whereas in unconventional machining process, we are clearly saying there is no contact between a tool and workpiece. Therefore, there is no chance of developing the forces, stresses between the tool and workpiece. So that is very important in unconventional machining process. So that is why it is called as unconventional machining process. This is also called as a non-conventional machining process too. So why the name is coming? Once again, I am clearing that the unconventional machining process is that there is no direct contact of tool and workpiece is that happens. So that is why the machining process is called as an unconventional machining processes. But where the tool wear is happen, tool wear is happen. There is no doubt about that. Okay, tool wear is happen. We are having there is more number of types of processes are available in unconventional machining process, like in conventional machining, lathe, milling machine, drilling machine, shaping machine, planing machine, like that. In unconventional machining processes, there is the different types of machines are available, like electrical discharge machining, electrochemical machining, electron beam machining, laser beam machining, plasma arc machining, ultrasonic machining, abrasive jet machining, water jet machining, like that. We have a nearly n number of machines, machining processes are available. Today in this class we are going to discuss those unconventional machining processes in detail. So, in engineering, we have studied this subject for a semester. Here, I would like to share the one semester subject I would like to cover in within a 30 minutes or a 45 minutes. How long it will go? Let it know. Within 1 hour, we will definitely have a complete detail about the unconventional machining processes. So, with this agenda, I would like to start the unconventional machining processes. Here, the unconventional machining processes are categorized in four different methods. One is a thermal energy method. That is, in thermal energy method, the workpiece will get melt and vaporizing or ablation is happening. Melting of the work material and vaporize it or ablate it. So it is happen in thermal energy method. In this method, electro discharge machining, electron beam machining, and ionized beam machining, laser beam machining, plasma arc machining or happens. In electric discharge machining, diffusion and vaporization is happen. Electron beam machining, melting and vaporization is happen. Ionized beam machining, bombarding of ionic particles. Bombarding means we are hitting the each ionized particles will hit the workpiece. So that is called bombarding. And next one is a laser beam machining. It is melting and vaporization. Plasma arc machining. It is again melting and partial vaporization is happen. The next method is electrochemical energy method. Electrochemical energy method. Here, electrochemical machining, electrochemical grinding, electrochemical honing, electrochemical discharging is happen. In electrochemical machining, ionizing, that is reverse of electroplating is happen. Reverse method of electroplating is happen. And next one is the electrochemical grinding. So electrochemical grinding is ionizing and abrasive action is happen. We know that grinding means the abrasion action is to be happen in grinding, honing, and deposition. All are abrasive action is happen. In grinding process, abrasive action, and electrochemical it is ionization. Therefore, in electrochemical grinding, it is ionization and abrasive action is happen. In electrochemical honing, the again anodizing and abrasive action is happen, and electrochemical deposition, anodizing and abrasive action is happen. Next one is a chemical method, that is chemical heat machining. Chemical heat machining. So that is etching processes is happen. CHM we have an etching processes, and in mechanical method pure erosion is happen. Erosion means we are tearing the material. Erosion means we are tearing the material. uh, so here the mechanical energy method, ultrasonic machining, abrasive jet machining, water jet machining, wire cut EDM, all are erosion methods will be happen. In increasing in order of MRR, that is metal removal rate. Which one is having a huge metal removal rate about these processes? Or in electrochemical machining will have a huge metal removal rate, where laser beam machining is having very minimal metal removal rate. If there is a plasma arc machining, definitely plasma arc machining will have a higher metal removal rate. If there is no plasma arc machining, ECM is having higher machining rate. So LBM, EBM, USM, EDM and ECM. So this is the increasing in order of metal removal rate. And minimum heat affected zone. Minimum heat affected zone is in ultrasonic machining. This ultrasonic machining is done for a brittle material and high toughness material. So that is our interest. So here I would like to give some of the figures which will show the different types of unconventional machining processes. So this is electro discharge machining. Here the workpiece is mounted in the table and surrounded by with the fluids. So the so it is electrochemical machining. I hope so. Dielectric fluid is there, workpiece is there, and nozzle will continuously pumping the fluid to the machined surface, and here it is an anode. So initially, if the anode is come nearer to the workpiece, the energy transfer is there, and as well as the high dielectric fluid is supplied, so the machining processes are controlled. Next one is the electron beam machining. So here the high velocity of electrons is passed, or it is concentrated on the workpiece. So the high velocity electron even the concentrated on the single point of an workpiece, definitely it wears the workpiece. So here we know that the electrons are very very less mass. Here we have to think one thing, that is how the energy, how the machining energy of electron is coming to picture. The electron which is having very very finite mass, very very lesser mass, but it is traveled at huge velocity. Therefore, the E is equal to mc square is coming to the picture. So C is the velocity. So mass into velocity square. If it is having high velocity, therefore the energy is huge. That is why the small, very very fine mass of the electron can machine the workpiece. So here we have in order to generate the electrons, the high voltage is being happen, and the cathode grid will produce the electrons, and anode, with the cathode and the anode the electrons is being produced, and the valve is there, valve, and magnetic lens is there. Magnetic lens is used to concentrate, it is used to concentrate the electron beams to the workpiece point. And here one thing you have to understand, the vacuum chamber is very very needed, because in vacuum the high velocity of the electrons is being achieved, and it will concentrated on the workpiece surface. If there is no vacuum, it won't concentrate, and the high velocity electron will hit the workpiece, the temperature is produced, and the melting and vaporization is being happen. So here the vacuum production is very very important, and the lens, magnetic lens, is also important. So next is a electrochemical machining. Here the pure chemical processes is happen. The electrolyte and having electrons will have a metal hydroxides, and we are adding anode and cathode. We are supplying the power to the workpiece as well as the tool, and the tool will always supplying the uh, chemical fluid to the workpiece. Here very accurate as well as high material removal rate is being achieved in electrochemical machining. Here ionization, that is reverse of electroplating is happen. So reverse of electroplating is happen, therefore material is removed. Here we know that, so this is the pump, and the workpiece is then anode, tool is a cathode, and dielectric current is being produced. So electrical current, positive and negative, is being supplied, and this one is the electrode, and here we have an positive and negative ions, electrons is there, and these electrons will carry a metals. So by means of an ionization, it takes the metal. Here one thing you have to understand, with the tool, here the tool wear is also there. Okay, here tool wear is also there. Okay, and next one is the electrochemical grinding. In the electrochemical grinding, grinding wheel is up, grinding wheel is also used. Similarly the electrolyte is being supplied, and positive to the workpiece and negative to the grinding wheel. Here the grinding wheel is made up of the metallic bond, then only it conduct electricity. By means of a grinding, that is abrasive as well as the ionization process. The ionization process is happened by means of an electrolyte, and abrasive action is being done by grinding wheel. So both will happens and produce very very fine surface finish to the workpiece. And here it is an, it is an ultrasonic machining. Here the abrasive slurry is being poured. Here it is the workpiece, here is the fixture, and this is the tool or a hammer. This tool or a hammer is connected to the horn This horn is connected to the piezoelectric transducer. When the high frequency of power is being supplied to this piezoelectric transducer, this horn will tend to move up and down very quickly. Very fast up and down action is being taken. Therefore, by means of the up and down action, it is connected to the hammer. What it will do, it will just hit the abrasive particles and workpieces. Therefore, erosion is happen just like a hammering of an abrasive particle on the workpiece. What will happen? It will erode the workpiece. So that is what it is happen here. One thing you have to understand that the hammer wear is also more, and hammer is supposed to be an hardest material. It should not take the abrasive particle, or it should not abrade by the abrasive particle. So like that we have to choose this hammer. And next one is the water jet machining or abrasive jet machining. The water jet machining is the high velocity of water, that is 700 meter per second of the water is being transferred with the fine diameter of nozzle, and that fine diameter of the nozzle with a small area and the huge velocity of the water is happen. Therefore, definitely it will cut the metals. The thickness of the metal should be limited in water jet machining. If it is an abrasive jet machining, instead of water, we use air plus abrasives. In water jet machining, water is being used, H2O is only used, whereas in abrasive jet machining, the high velocity of air and abrasive particles, fine abrasive particles, is being used. Here, the fluid is supplied from the tank, and it is supplied by means of a pump to accumulator, and the controls and hydraulic unit, high pressure and high velocity control units and accumulator is there, and valves are being used, and supplied nozzle, and will supply the high velocity of water to the workpiece. So next one is the wire cut EDM. The wire cut EDM, it is very similar to electrical discharge machining, where here the electrolyte is also used. Ionized water, deionized water is being used as an electrode, and copper or tungsten or copper tungsten mixer wire is being used. In the wire which is wounded between two pulleys, the spark is produced between the work and the tool material. The spark quantity is 2.5 lakh per second. So this much of spark is being produced. So that much spark will easily melt and erode the workpiece, will melt and erode the workpiece. So here the workpiece is connected to the negative supply, and sorry, workpiece is supplied to the positive supply, and wire is connected to the negative supply. Therefore, a small gap, the high velocity or high frequency of the spark is being produced, and the metal is being cutted, okay, like this. A spark gap, very minimum spark gap is there, and also deionized water is being used. Very fine drillings can be made. So a very high accuracy of profiles can be made by this wire cut EDM machine. So what is the major disadvantage is, so before machining any profile, we have to make a hole on the workpiece. So whatever may be the workpiece, how hardness it is, it doesn't matter. We should make a fine hole for insert the workpiece, wire in the workpiece. So this is the major disadvantage of the wire cut EDM. Once the wire is getting in the workpiece, then only any complicated profiles can be made. So with this diagrammatical information, I would like to give a brief theory and comparison about the unconventional machining processes. This is process comparison, and I am going to take nearly an 8 type of process, which is very very important, and we should know this 8 process. And I'm going to make this as a row, and in the first column the different types of techniques is being postulated. Here the process parameters: first, material removal rate. For electrical discharge machining, a powerful electric spark is being used. In electrochemical machining, it is based on Faraday's law of electrolysis. And electron beam machining, high velocity beam of electron is being passed. Laser beam machining, by high intensity of laser beam is used. In plasma arc machining, heating and melting and vaporization using plasma arc. In ultrasonic machining, slurry of small abrasive particle is forced against the workpiece by means of a vibrating tool. In abrasive jet machining, by high stream of abrasive particles mixed with air is being used. And water jet machining, high velocity of water jet is used. So this is the metal removal technique used in different processes. Next is the work material. So next is the work material. Which kind of a work material can be employed? In electrical discharge machining, electrically conductive metals and alloys is being used. So this is very very important. So in electro discharge machining, the workpiece should be electrically conductive. In the electrochemical machining, whatever the material, it is very difficult to machine, but it is a conductive material. It can be used for electrochemical machining. In electrochemical machining also, the conductivity, electrical conductivity also there. And with the electrical conductivity, if the metal is, it is very difficult to machine, like a tungsten or titanium can be machined in electrochemical machining. In electro beam machining, all materials can be used, whatever may be, either it is a soft or tough or ductile or brittle, anything can be used. In laser beam machining, so all materials except high thermal conductive and high reflective. We can't use a reflective material, because if the reflective material reflects the laser to the different direction, different position, it will continuously travel. So laser having a property of, it will continuously travels against this a small gap. So if there is a material of reflective kind of things, it reflect the laser beam to another areas, those areas will get damaged. That is why the high reflective materials cannot be used, and high conductive materials also cannot be used, because the high heat is being used, melting and vaporization is happens. Therefore high thermal conductive material is easily melt. So that is why in plasma arc machining, all materials which conduct electricity, can be used. In ultrasonic machining, tungsten carbide, glasses, quartz, germanium, ceramics, etc. are being used. That is, brittle materials can be excellently machined using ultrasonic machining. In abrasive jet machining, hard and brittle material like glass, quartz, ceramics are being upgraded. In water jet machining, soft and non-metallic metals like plastic, paper boards, like these kinds of materials can be worked in water jet machining. Next is the tool material. What are the tool material which is done for machining? First, in the electron beam, electron discharge machining, copper, yellow brass, alloy of zinc, copper, tungsten are being used as a tool material. In electrochemical machining, copper, brass, titanium, copper, tungsten, stainless steel are being used as a tool material. In electron beam machining, it is an electron beam. In laser beam machining, it is a laser beam. In plasma arc machining, it is plasma. And ultrasonic machining, low carbon steel or stainless steel is used as a tool material. In abrasive jet machining, abrasives like aluminum oxide, silicon carbide, glass powders are being used. In water jet machining, only a jet of water is being used. Jet of water at high velocity. Jet of water at high velocity is being used. Next is the material removal rate. The material removal rate of different machining processes. For EDM, it is 15 to 20, 80. It is 15 to 80. That is meter cube per second. Material removal rate in meter cube per second. In ECM, it is 27, and EBM, it is 15 to 40. In laser beam machining, it is zero point 0.1. In plasma arc machining, it is 2500. In ultrasonic machining, it is 14. In abrasive jet machining, it is 0.014. In water jet machining, it is zero point 0.6. So 0.6 meter cube per second of the material can be removed. If we compare these processes, the plasma arc machining is having a high material removal rate. After that, electro discharge machining. After that, the electron beam machining and electrochemical machining. So in because of it is having ranges, the electron discharge machining and electron beam machining is having a ranges. We are having the second largest material removal process is electrochemical machining process. It is definitely having 27 millimeter cube per second is being eroded irrespective of the supply, irrespective of the processes. So ECM is be a second material removal rate processes in unconventional machining processes. So next is the surface finish. So surface finish, which is very important. The surface finish in micrometer. Surface finish in micrometer. In EDM, this is EDM. In EDM, 0.25 micrometer of surface finish can be gotten. In ECM, it is 0.2 to 0.8. In EBM, it is 0.4 to 0.6. In laser beam machining, it is 0.4 to 0.6. In plasma arc machining, since it is having high metal removal rate, the surface finish is very rough. In ultrasonic machining, it is 0.2 to 0.7. In abrasive jet machining, it is 0.2 to 1.2. And in water jet machining, it is 0.5 to 0.8. Therefore, since in electrochemical machining can produce very fine surface finish, so that is why it is recommended. Electrochemical machining, it is having very high material removal rate, as well as it will produce a smarter surface finish when compared to other processes. As a electrochemical machining, the ultrasonic machining is also capable of producing a very fine surface finish. After that, the electro discharge machining will produce. So this is first, this is second, so this is third one. Okay, so next is the power requirement. Next is the power requirement. So power requirement in EDM, very low power is needed. ECM, medium power is needed. Electron beam machining, very low power is needed. Low power is needed. Laser beam machining, very low power. Plasma arc machining, very low power. Ultrasonic machining, low power. Abrasive jet machining, low power requirement. Whereas water jet machining, which needs high power requirements, because it is producing a high velocity of water stream, nearly a 700 meter per second of velocity. You can imagine that for producing those very high velocity, how the pump is required. So that is very important. Pump and storage device and the supply hoses which the hoses is very important. It should supply without damaging. It should supply the 700 meter per second velocity of water stream, and it should not machined at that velocity. So that is very important. And next is the capital cost. That is, capital cost is the initial cost. So initial cost, electro discharge machining is medium, electrochemical machining is high, electro beam machining is high, laser beam machining is high, plasma arc machining is low, ultrasonic machining is high, abrasive jet machining it is very low, and water jet machining it is high. And next we are speaking about the efficiency of the machining processes. In electro discharge machining, the efficiency is high. Electrochemical machining, the efficiency is low, since the tool wear may happen. In electro beam machining, very high efficiency. Laser beam machining, it is very high efficiency. Plasma arc machining, it is having very low efficiency because of the rough surface finish. In ultrasonic machining, which is having high efficiency, abrasive jet machining is having high efficiency, water jet machining is having high efficiency. So next is the application. So next is the application of these machining processes. The applications, like in EDM, very complicated irregular shapes and a resharpening of cutting tools can be done in electro discharge machining, whereas in electrochemical machining, hard complex shape parts can be machined. In electro beam machining, micro machining on thin material like drilling, slotting, scrubbing can be done in electro beam machining. In laser beam machining, drilling of micro holes up to 250 micrometer. So this is very important. Up to 250 micrometer and cutting very narrow slots. So before wire EDM, we always prefer this laser beam drilling, in order to insert the copper wire or copper tungsten wire in the work material. So before wire cut EDM, we used to drill the workpiece by means of a laser beam machining. That is, very fine hole can be produced. So 250 micrometer hole can be produced. Very narrow slots can be produced by means of laser beam machining. In plasma arc machining, profile cutting on SS, so that is stainless steel, monel, and super alloy plates can be easily machined by means of plasma arc machining. Whereas in ultrasonic machining, hard, brittle material like glass, ceramic, tungstens can be machined. The application of abrasive jet machining is intricate hole shapes in hard and brittle materials can be produced by means of abrasive jet machining. In water jet machining of machining of non-metallic materials can be machined by means of water jet machining. So next is the last thing, that is the limitation of the processes. The limitations of the processes. First one, the EDM, which is not suitable for non-conductive material. So electro discharge machining, so it is not suitable for non-conducting material. A material should conduct electricity can be uh, machined by means of electro discharge machining, electrochemical machining. So for these two, the material, workpiece material should be a conductive material. And electron beam machining is not suited for large workpiece. So large workpiece it is not suited because it need a vacuum. It need a vacuum. So vacuum for the large space or large workpiece, we cannot create the efficient vacuum. That is why it is having in the limitation parts. The smaller workpieces can be machined by means of EBM process. In laser beam machining, a taper of 0.05 millimeter when work thickness is more than 0.25 millimeter. When it get machined, the laser beam penetrates the workpiece, and it will again the laser beam is narrowed down by means of an workpiece surface. Therefore, a small taper is being there in machining of laser beam machining. So that is a very important problem. And next one is a plasma machining, very low accuracy. Since the material removal rate is high, surface finish is rough, it is having very low accuracy. In ultrasonic machining, low metal removal rate, high tool wear rate. So this is very important point. High metal removal, low metal removal rate and high tool wear. So that is the problem. And in abrasive jet machining, low material removal rate and low accuracy. This is a limitation. In water jet machining, difficult to machine hard materials. Hard materials are difficult to machine in water jet machining process. So with this, I have given an enough detail about the ultrasonic machining processes. So 10 process parameters are compared to 8 processes. So it is a very huge. So with this, I hope I have given an enough knowledge about the unconventional machining processes. So if you have any doubt on this, please let me know in the comment section. I'll put that definitely in another video for your clearing your doubts. Until bye bye from Santhosh. Thank you for patient listening. Thank you all.